Morning to all of you. This is Muva Prasad signing into DCEB Suryapeta online live streaming classes. We are in the first topic, that is real numbers, which is completing in the end of our complete syllabus. So which is introduced by our Ashok sir, already given 2 classes on the real numbers. And the first exercise almost all is completed and going for the next second exercise. And real numbers basic concepts already Euclidean division algorithm and LCM and HCF are already discussed to you. So remaining part of the real numbers will be discussed by our Ashok sir. Ashok sir, please go through the concept.
Thank you, sir. So good morning all of you. So this is our third class in real numbers. So we'll continue the class. So before going to start the class, I asked one question in the last class. In case of while discussing prime numbers and composite numbers, 2, 4, 6, 8 and so on are even numbers. 2, 3, 5, 7, 11 and etc. are prime numbers. 4, 6, 8, 9 and so on are composite numbers. I asked what about 1? Is it prime or composite? Yes, it is neither prime nor composite. Why? Because if you want to say a number is prime number, it should contains 2 factors. If it contains more than 2 factors, it is called as composite number. So 1 contains only 1 factor, that is 1 only. So it is neither prime nor composite. Okay. Now move to today's class. Look at example number 3. Consider the number of the form 4 to the power of n, where n is natural number. Check whether there is any value of n for which 4 power n ends with 0. You have to check whether this ends with 0. For any value of n, here n is natural number. If you put for any value of n, can 4 power n ends with 0 or not? We have to check. Before that, take few numbers ending with 0. If you write the prime factors of that number, look at here, the number 10. So ends with 0. Its prime factorization is 2 into 5. 20. So 2 into 10, again 10 can be written as 2 into 5. So prime factorization of 20 is 2 into 2 into 5. Look at 30. 2 into 3 into 5. 50. 5 into 5 into 2. Already we know how to write the prime factorization of a number. So already we discussed in the first class. So take 100. So its prime factorization is 2 into 2 into 5 into 5. So by observing all these examples, I have taken all the numbers which are ending with 0, means in units place 0. So its prime factorization contains only 2 and 5. Okay, that means any number that ends with 0, it should contains 2 and 5 in prime factorization. So a number that ends with 0, it should contains 2 and 5 only as prime factors. So if you write the prime factorization of a number, it contains only 2 and 5 as prime factors. So clear that ends with 0. So basing on this, look at our sum 4 to the power of n. So I am writing 4 as 2 square. Okay. to the power means we multiply, so it becomes 2 to the power of 2n. Here what is n value? N is natural number. So if you put 1 or 2 or 3 and so on, so it doesn't contains factor 5. For any value of n here, if you write the prime factorization, it contains only 2. It doesn't contains 5. So in the previous example, what we have seen, any number that ends with 0, its prime factorization must contains 2 and 5. Here only 2. So there is no natural number for which 4 to the power of n ends with the digit 0. So clearly 4 to the power of n does not ends with the digit 0. Okay. In prime factorization of 4 to the power of n, 2 and 5 will there, then it ends with 0. But 4 to the power of n in its prime factorization only 2 is coming. So 5 is not there. So 4 to the power of n. So there is no natural number for which 4 to the power of n ends with the digit 0. So in this way you have to solve the sums. Similar sum is there in exercise 1.2. Look at third sum. So check whether 6 to the power of n can end with the digit 0 for any natural number n. So you have to do as homework. So you have to try this one, same as just now what I have discussed. Okay. Now moves to next term. Look at fourth sum here. Explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. So you have to say the reason why these are composite numbers. So the given two numbers are, first one is 7 into 11 into 13 plus 13. Before doing the sum, you have to have a clear idea about composite numbers. What is composite number? How can you decide whether a number is composite or prime? So if the number contains more than 2 factors, that is called a composite number. We know very well every number, each and every number except one, every number has 2 factors, one and itself. If you show there is one more factor other than one and itself, clearly that is a composite number. Okay. Now it has 2 terms, 7 into 11 into 13 plus 13. In these 2 terms, 13 is common there. Okay. We know prime number has 2 factors and composite number has more than 2 factors. So I am taking 13 common in this one. So 7 into 11 into 13 plus 13. In this one I am taking 13 common. So 13 into 7 into 11 plus 1. So 11 7 ja 77 plus 1 78. So this number contains 2 other factors, 13 and 78. Actually, you don't know what is this number. If you multiply all these and plus add 13, you will get the number. But without knowing the number, this number contains one and itself as factors, and we are showing 13 and 78 are other 2 factors. Means it contains more than 2 factors. So clearly it is a composite number. Understood? 7 into 11 into 13 plus 13. It is a number. Actually, I don't know. If you multiply all the and add 13 to this one, you will get the number. But this number contains one and itself are factors, and we are showing 2 other factors, 13 and 78. Means it contains more than 2 factors. So it is clearly it is a composite number. Okay. Look at this sum. Very simple thing. Here also two terms are there. In these two terms, 5 is common. Okay. Take 5 common out. So 5 into, if I take 5 common out, 5 into 7 into 6 into 4 into 3 into 1 plus 1. Without multiplying this one, clearly for this number, 5 is one more factor. Instead of multiplying and adding this left out. So we know this number has 1 in itself or 2 factors, and we are showing 5 is one more factor. Okay. So means this number contains more than 2 factors. That's why it is a composite number. Okay. We know every number has 2 factors except 1. So 1 in itself. So if a number contains more than 2 factors, that is called a composite number. Here we are taking 5 common out. So 5 is one more factor, means 1 in itself and 5 is a factor. So this number contains more than 2 factors. So clearly it is a composite number. So this question comes in the examination. So you have to, basing on this, you may create a few new sums. So try this one. Now comes to next topic, rational numbers and their decimal expansion. So remaining sums in the exercise 1.2 I am giving as homework. So my dear students, all of you practice, and if you have any doubt, ask your teachers. Okay. Now rational numbers and their decimal expansions. So initially we have discussed what is rational number. Rational number is in the form of p by q, where p comma q are integers and q is not equal to 0. So we indicate the letter with q. So rational numbers would be in either a terminating decimal form or non-terminating repeating decimal form. So every rational number would be in either a terminating decimal form or non-terminating repeating decimal form. So in these two ways we can represent rational numbers. Okay. Now first of all we will look into terminating decimals. I am taking 0.375 is terminating decimal. So look at these few examples. After the examples, our conclusion will be as theorem I say. Okay, 0.375. So it can be written as 375 by 1000. So already we learned how to write decimal form into fraction form. So remove this decimal point, write as is in the numerator 375 by, for decimal point put 1. How many digits are there? 1, 2, 3. Put 3 zeros. So 0.375, that is equals to 375 by 1000. If you divide 375 with 1000, you will get 0.375. So now I want to write the prime factorization of both these numbers. Means the numerator and denominator, I am writing prime factorization. Okay, 375. So here, look at here, 5 7s are 35, 2 is remainder 25, 5 5s are 25. Okay, next with 5, 5 1s are 5, 2 remainder 5 5 are 25, 5 3s are 15. So 375 can be written as 3 into 5 into 5 into 5. So we know 1000 means 10 cube. I am writing 10 as 2 into 5. So 10 cube means 2 cube into 5 cube. Here 3 into, it is 3 into 5 cube. This 5 cube will get cancelled. Will get only 3 to the power of 1 into 2 cube. Observe this one, denominator. Prime factorization of denominator of decimal form is, here we are getting 2 cube. So if we simplify 3 by 8, means you convert from decimal to rational number, fraction form, it is 3 by 8. Look at one more example. 1.04. So it is also a terminating decimal. So look at the end point, what we are getting in the denominator. So basing on this denominator, we will have some conclusion. Look at here, 1.04. If you remove point, write as it is in the numerator, 104 by, for point put 1, and for 2 digits put 2 zeros. So 1.04 becomes 104 by 100. Now write the prime factorization of 104. What do you have? 2 5 are 10, 2 2 are 4. 2 2 are 4, 1 remainder 12, 2 6 are 12, 2 13 are 26. Now 104 is, its prime factorization is 2 into 2 into 2 into 13 by 100 means 10 square. Already I told you 10 means 2 into 5. So for 10 square, 2 square into 5 square. So it is 2 cube, 13 is there, and 2 square and 5 square. So if you do cross, so it becomes 2 into 13 by 5 square. So 2 into 13, 26 by 5 square, 26 by 25. So in the earlier example, 0.375, after writing in the P by Q form, the denominator, the prime factorization of denominator contains 2 cube and here 5 square. Okay. The previous example 0.375. At the end we get, I think 3 by 8 something. 3 by 8. Here, after writing in the P by Q form, the denominator, prime factorization of denominator contains 2 cube. In this example, the prime factorization of denominator, and after writing P by Q form, so it becomes 5 square. Okay. Remember these 2 points. Next we'll see one more example. 0.0875. It is a terminating decimal. Okay. So if you write in the P by Q form, it becomes 875 by 10,000. Okay. After removing the decimal point, write the same enter value as numerator, and for point put 1, and 4 digits there, put 4 zeros. So 875 by 10,000. So 875, its prime factorization is, so 5 1 ja 5, 5 7 ja 35, 5 5 ja 25, 5 3 ja 15, 5 5 ja 25, 5 7 ja 35. So 875 is equals to 5 into 5 into 5 into 7. So for 10,000, 10 to the power of 4. Okay. So it becomes 5 cube into 7 by 2 to the power of 4 into 5 to the power of 4. Here 3 5s are there. So it is 5 cube into 7 by 2 to the power of 4 into 5 to the power of 4. Okay. Now after cancellation, you have 7 by 2 to the power of 4 into 5. Okay. Before multiplying these two, observe. So the terminating decimal, if you write in the P by Q form, the prime factorization of denominator here contains 2 and 5. So in the last two examples, the first one, 2 power something is there, and in the second example, 5 power is there. So in this one, both are appearing. So after all these 4 examples, we will come to some conclusion. Now this is 7 by 2 to the power of 4 means 16, 65 is 80. So 0.0875. If you write in the P by Q form, it is 7 by 80. Now look at the last example, 12.5. Okay, if you remove this 0.5, it becomes 125 by 10. For point, put 1. For 1 digit, put 1 0. So 125 by 10. So 125 can be written as 5 into 5 into 5. So 5 2 is 10, 2 remainder, 5 5 is 25. Again do with 5, 5 5 is 25. So 125 is equals to 5 into 5 into 5. For 10, we write 2 into 5. Okay, after cancellation of these two 5s, you have 25 into 5, 25 by 2. Okay, after observing all the 4 examples, so our theorem is, look at here. Let x be a rational number whose decimal form terminates. Just now we have seen 4 examples. We have taken all the 4 are terminating decimals. Okay. Let x be a rational number whose decimal form terminates. Then x can be expressed in the form of p by q. Then x can be expressed in the form of p by q, where p and q are co-primes. Where p and q are co-primes. And the prime factorization of q is of the form 2 to the power of n and 5 to the power of n. Either 2 power or 5 power or both will come in the denominator. Okay, so here m and n and m are non-negative integers. Okay, so after observing all the 4 examples of terminating decimals, terminating decimal can be expressed in the form of p by q, where the prime factorization of denominator means q, that should be in the form of 2 to the power of n into 5 to the power of m. Okay, this is the theorem 1.3. So basing on the 4 examples, this is the theorem number 1.3. Okay, so basing on this, you have to solve few more sums in the do this topic. So do this. So you have to write the p by q form of these 4 or 5 questions he has given, and after writing p by q form, write the denominators in the 2 to the power of n into 5 to the power of m form. So whatever we have discussed, the 4 sum, so do practice all these the same way. Okay, now comes to next topic. So in the previous example, 0.375 decimal form has given, we will modify it into fraction form. Now it is reverse. Look at here, 3 by 8. Okay, so 3 by 8 means now means we are going to write the decimal form of the given rational number. Okay, here without doing, actually if anybody asked us to write the decimal form, simply what will we do? We divide 3 with 8. You can write a decimal form. So here we are not doing actual division. So see how I do. 3 by 8. Okay, 3 by 8 can be written as 2 cube. Prime factorization of 8 is 2 cube. So mind one thing, if any number in the denominator of any rational number, if 10, 100, 10,000 or 10,000 will come, then without doing the division, basing on the zeros, we will write the decimal form of a number. For example, 3 by 10 means 0.3. 3 by 100 means 0.03. Like that, here without doing actual division, I write the decimal form. Look at here, how I can. So 3 by 8 means I am writing the prime factorization of 8, that is equals to 2 cube. So 3 by 2 cube means here I need to have 10 or 100 or 1000. Okay, 2 cube means to get 10, I need to multiply 5 cube. So power will be same. So I am multiplying both numerator and denominator with 5 cube. So now 5 cube means 125, 125 into 375. Here 2 into 5, 10, 10 cube. 10 cube means 1000. So in the denominator 10,000, 1000 means 3 zeros. So simply put a decimal point, move decimal point left three digits. How many zeros will appear in the denominator? Move the decimal point left to 3 digits. So 375 by 10 cube means 1000. That is equals to 0.375. Okay. Now look at one more example. 7 by 80. Okay. Now 7 is a prime number. Keep it as same. 80 can be written as its prime factorization becomes 2 to the power of 4 into 5. Okay. If 5 contains to the power 4, then it can be written as 10 to the power of 4. So here for to get equal powers, so I am multiplying both numerator and denominator with 5 cube. Why? Already 1 5 is there. So if you multiply with 5 cube, so 7 into 5 cube by this denominator becomes 2 to the power of 4 and 5 to the power of 4. Okay, now it can be written as 10 to the power of 4. To get 10 to the power of 4, you have to make equal the powers of both 2 and 5. Okay, so now 5 cube means 125, 5 into 5 into 5. If you multiply 125 into 7, you get 875. But this is 10 to the power of 4. Simply remind one thing, power 4 means you have to move the decimal point towards left side up to 4 digits. So actually 875 means even though we didn't put a point is there. Okay, move this point to 4 digits left side. Means here only 3 digits are there, put 0. So now it becomes 0.0875. So here what I am doing, without doing the actual division, I am writing the decimal form. If you ask this question to 9th class student or 8th class student, you can also write the decimal form, but by doing the simple division. If you divide 7 with 80, you can write this decimal form. But here what I am doing, here without doing actual division, I am writing the decimal form. You have many questions same as in the exercise and do this activity. So you have to solve like this. Now look at one more example. 26 by 25. Okay, 26 by, first of all, I have to write the prime factorization of denominator. So it is 25 there. Now it becomes 5 square. Okay. Now to get 10 square, we require 2 square. What is the power that 5 has? You have to multiply the same power with 2. If we multiply with 2 square, so 26. Here 26 can be written as 13 into 2. And again we are multiplying with 2 square, both numerator and denominator. Okay. Now it becomes 13 into 8, 104 by 2 square into 5 square. That is 10 square. So 10 square means put decimal point after 2 digits. Now it becomes 1.04. Okay, 26 by 25, its decimal form is 1.04. I am repeating once again. So 25 prime factor is 5 square. So 5 square is there. So multiply with 2 square, both numerator and denominator. This 2 cube is initially has written 26 as 13 into 2. So that 2 square, already 2 is there. So that becomes 2 cube. Now this 2 square into 5 square, 10 square. So here 13 into 8, 104. So square is there. So 2 means you have to put the point, decimal point after 2 digits. Okay. Now 25 by 2. Here only 1 2 is there. Okay. So to get 10, multiply with 5, both numerator and denominator. Here 25 can be, he has written as 5 square and we are multiply with 1 5, another 5. That becomes 5 cube, 125. By 2 into 5, 10. So only 1 0 is there, means 1 power 1 is there. So put point after one digit. Okay, so 125 by 10, that is equals to 12.5. So by observing all these 4 examples, so what can you say? What is your conclusion? Look at this theorem number 1.4. Okay, let x is equals to p by q be a rational number. Let x is equal to p by q be a rational number such that the prime factorization of q is of the form 2 to the power of n into 5 to the power of m. The prime factorization of q is of the form 2 to the power of n to 5 to the power of m, where n and m are non-negative integers. Then xa has a decimal expansion which terminates. Then xa has a decimal expansion which terminates. After taking a rational number in the form of p by q, if you write the prime factorization of q, it contains 2 and 5 in this form, then clearly terminates. More than these, if any number appear 3 or 7, that is not terminates. Okay, so this is the theorem 1.4 says. What says means x is equals to p by q be a rational number such that the prime factorization of q is of the form 2 to the power of n into 5 to the power of m, where n and m are non-negative integers. Then x has a decimal expansion which terminates. Basing on the 4 examples what we have discussed till now, from those examples, this is the conclusion theorem 1.4. Okay, so basing on this, solve these problems. These are homeworks for you. After completion of this class, you have to solve all these and clearly note in the fair notes. So basing on these, we will allot format assessment marks. Okay, keep it in mind. Now, these are the exam homework for you. Now, look at 1 by 7. Its decimal form is, we know very well, 0.142 857 and so on. So is non-terminating and repeating decimal. Look at 1 by 3. Also 0.333 is non-terminating and repeating decimal. And 5 by 11, 0.45454545 is 45 is repeating again and again, is non-terminating and repeating decimals. Why these are non-terminating? Come on, tell me. Yes, think once. So just now we have discussed theorem 1.4. Denominators not in the form 2 to the power of n into 5 to the power of m. If denominator of these numbers in this form, so then surely there will be terminate. But the denominators of these numbers not in this form. That's why they are not terminating. So basing on this, look at one more theorem. Let x is equals to p by q be a rational number such that the prime factorization of q is not of the form. Prime factorization of q is not of the form 2 to the power of n to 5 to the power of m, where n and m are non-negative integers. Then x has a decimal expansion which is non-terminating repeating. So with the theorems 1.4 and 1.5, so what we can understand, if any rational number in the form of p by q, if you write the decimal, if you write the prime factorization of denominator, in that if you have 2 to the power of n into 5 to the power of n in that form, so that is a terminating decimal. Otherwise, that is not terminating and repeating decimal. Okay. So any rational number that is in the form of p by q, if you write the prime factorization of q, if that is in the form of 2 to the power of n into 5 to the power of m, so clearly that is a terminating decimal. Otherwise, that is a non-terminating and repeating decimal. Okay. Now comes to few sums basing on theorems. Just now what we have discussed. Look at example number 5. Using the above theorems, means 1.3, 1.4 and 1.5. So whatever you need, we have to apply. Without actual division, keep this, underline this word. Without actual division, state whether decimal form of the following rational numbers are terminating or non-terminating, repeating decimals. You have to state whether these are terminating decimals or non-terminating repeating decimals without doing the actual division. So it is easy for us, for 10th class students only. This sum is where they can't do for 9th class students, because just now we have learned theorems 1.4 and 1.5. So basing on that, without actual division, so we are able to say whether these are terminating or non-terminating. So look at example number 1, 16 by 125. So forget about numerator, think about only denominator. So 125 can be written as 5 into 5 into 5. Okay, 16 by 5 cube. Okay, this denominator contains only 5 cube. So clearly it is a terminating decimal. So in the denominator of 16 by 125, so the prime factorization contains 5 cube, means it is in the form of 2 to the power of n into 5 to the power of m. Okay, if you put for n equal to 0, we write here 2 to the power of 0. So in the denominator, only 5 cube is there. If 5 comes or 2 comes, they are terminating. Look at example number 3. Here in the denominator, 3 came. So it is not terminating. So if only 5 or 2 or both 2 and 5, if they come, then they are terminating. So along with 2 and 5, look at example number 4. Here 3 came. So it is also non-terminating. Okay. So comes to example number 1. 16 by 125. So these two are co-primes. So 125 can be written as 5 cube. In the denominator only 5, prime factorization contains only 5 cube. So it is a terminating decimal. Look at this one, 25 by 32. 25 by 32 means 2 to the power of 5. We know very well, 2 into 2, 2 into 2, 2. So it can be written as 2 to the power of 5. Means the denominator contains the prime factorization of denominator is of the form 2 to the power of n into 5 to the power of m. So only 2 came, so it is a terminating decimal form. Look at example number 3, 100 by 81. 100 by 81 means its prime factorization is 3 to the power of 4. 3 into 3, 3 into 3. Okay. Here, look at here. Here, the prime factorization of denominator contains 3 to the power of 4. No 2, no 5. 3 to the power of 4 came. So clearly it is non-terminating repeating decimal. Non-terminating and repeating decimal. In the example number 4, 41 by 75. Okay. 75 can be written as 3 into 5 into 5. Okay. Look at here. 41 by 3 into 5 square. So here, along with 5 square, 3 is there. So clearly it is non-terminating. Means in the prime factorization of denominator of a rational number that contains only 2 and 5 or 2 or 5. So if any number comes along with 2 and 5, that is clearly non-terminating. Okay. So in this way, we can say where the rational numbers means in the form of p by q, whether they are terminating or non-terminating without doing actual division. So basing on this, you have to solve the few sums in the exercise. Okay. Comes to next sum. Example number 6. Okay. Look at the question once. Write the decimal form of the following rational numbers without actual division. Write the decimal form of the following rational numbers without actual division. Simply keep an point in your mind. Without the actual division, if you want to write the decimal form, so it should contains the denominator 10 or 100 or 1000 or anything. Means 10 to the power of 1 or 10 to the power of 2 or 10 to the power of 3 and so on. So then only we can write the decimal form without doing the actual division. Okay. 35 by 50, the first sum. 35 by 50. So it can be written as 7 into 5. 50 can be written as 2 into 5 into 5. 1 5 will get cancelled. We have 7 by 2 into 5. 7 by 2 into 5. So 7 by 10. So means 10 or 10 to the power of 1 means you have to put the decimal point 1 digit left to that one. That becomes 0.7. Okay. Here we didn't do the actual division. Basing on the denominator, the powers of 10, we are putting decimal point. Now look at second question, second bit. 21 by 25. So 25 can be written as 5 into 5. Means 21 by 5 square we are getting. 5 square means we need 2 square to get 10 square. Here we have 21 by 5 square. So to get 10 square, we need to multiply this with 2 square, both numerator and denominator. Now 21 by 5 square into 2 square by 2 square. So 2 square means 4. It becomes 84. Look at denominator. 5 square into 2 square. It is now 10 square. So 10 square means we have to put decimal point before 2, move left side 2 digits. Actually 84 means decimal point here is here. Move 2 digits left side. So now it becomes 0.84. The decimal form of 21 by 25 is 0.84. Like this, you have to solve the problems without doing actual division. Now look at third sum. 7 by 8 is equals to 7 by 8 can be written as, we know very well, 2 cube. Okay, 2 cube means we require to multiply both numerator and denominator with 5 cube. Why? To get 10 cube. Here 2 cube is there. If you multiply the 5 cube, so now 7 into 5 cube means 125. Sorry, here 1 is not visible. It is 125. 7 to 125 by 2 into 5 to the power of 3. That becomes 10 cube. Now 875 by 10 cube. Cube means you have to put the decimal point after 3 digits towards left side. So it is 0.875. Okay. In this way, you have to write the decimal form of a rational number without doing the actual division. So you have few sums in exercise 1.3. So you have to solve all these sums. Look at first question. Write the following rational numbers in their decimal form and also state which are terminating and which are non-terminating repeated decimals. Just now we have solved this type of problem. Look at second one. Without performing division, state whether the following rational numbers will have a terminating decimal form or non-terminating repeating decimal form. Just now we have solved this type of problem. So in this, I tell one sum. So look at the third bit and third sum and fourth sum, all the homework for you. So look at the eighth bit in the second sum, 9 by 15. Okay. So you have to write the prime factorization of both numerator and denominator. So why I am telling is, here the prime factorization of denominator contains 3 into 5. So first of all you have to cancellation, you have to do the cancellation. So then you will get 3 by 5. Okay, 3 by 5 means denominator contains only 5. So it is a terminating decimal. Okay, without doing cancellation, so 3 into 5 appears, so don't write it as a non-terminating, but after cancellation we have only 3 into 3 by 5. So in the denominator 5 is only one factor, so 9 by 5 is a terminating decimal. I will end with one sum, 77 by 210. Here also 77 means 7 into 11, 210 means 2 into 105, 2 into 3 into 35, 2 into 3 into 5 into 7. I am writing the prime factorization. So 77 by 210 is equals to 7 into 11 by 2 into 3 into 5 into 7. After cancellation of these 7, you have 11 by 2 into 3 into 5. So in the denominator, along with 2 and 5, 3 is one more factor. So clearly it is non-terminating and repeating decimal form. Okay. So this is today's class. With this I am completing. Thank you, sir. Prasad sir.
Okay, sir. So screen share up. So that is the end of the today's session. In how to convert a rational number into a decimal form without actual division, and what are the process of learning while doing that sums, and what are the techniques to achieve that one as early as possible to get the solution, and what are the defects we are doing while you are solving the sums in that one. So that is explained by our Ashok sir completely, and go through the remaining questions which are in the left in the exercise questions. Thank you very much for the technical team who supported for online live streaming classes. See you tomorrow at